Welcome to solverfy.
So now we'll work on problem 66 from chapter 17. In this problem, we're asked to, from the value of Kf listed in table 17.1, calculate the concentration of NH3 required to just dissolve 0.02 moles of nickel oxalate, which has a KSP of 4 times 10 to the minus 10 in 1 liter of solution. And we're told that we can neglect the hydrolysis of the oxalate anion because the solution will be quite basic. So from this table mentioned here, the Kf value for the formation, of nickel, the complex anion, which will be shown here, is 1.2 times 10 to the 9. So we can go ahead and draw out 2 reactions. One is for the solubilizing of the nickel oxalate. So nickel C2O4 can go to nickel 2 plus C2O4 2 minus, and this has a KSP which is equal to 4 times 10 to the minus 10. And then we also can have the formation of this complex ion, which is nickel 2 plus 6 ammonia, gives nickel NH3 6 2 plus. And as we mentioned before, this has a Kf of 1.2 times 10 to the 9th. So we can go ahead and sum up these reactions. And we get, we have the nickels will cancel. And so we get this nickel oxalate reacting with 6 ammonia molecules to form this complex ion and the oxalate anion. So we can make an ice table here. We don't have any initial ammonia, or we don't know the initial ammonia. We need to know the exact amount of ammonia that we need to add. So we know that we're going to subtract 6x, and we're going to create, we're told from the problem, 0.02 moles of this ion, or of dissolving of this ion in solution of 1 liter. So we have an equilibrium of 6x and 0.02 for both of these. So we can open up a new page to do our calculations. So K, which we'll calculate back on the first page here, K is equal to 4 times 10 to the minus 10 times 1.2 times 10 to the 9. Since we added the reactions, we're going to multiply the K values, and we get 0.48 as our K value. So K is equal to 0.48, which is equal to our products over reactants. So we have 0.02 squared over 6x. And so if we solve for x, we get an x value of 0.0139 molar. And we know that the concentration, which is what we are asked about in the initial problem, the concentration of ammonia, has to equal 6x. So if we multiply our x value by 6, we get a value of 8.33 times 10 to the minus 2 molar.